Well, welcome to our third video about this series of videos about simulating cotton harvesting and the model behind it. Today we will be talking about interpreting the outputs. Alright, well today we're going to talk about the outputs that come from the simulation model. In the first two videos I showed an introduction to the model, and in the second video I showed how the inputs work that you can change that go into the model. In this video we're going to show what you get out of the model and how you can use that maybe when you're trying to construct a bot harvesting system to make it comparable to a deer system. So again, we kind of start on this home page and you have look at the story. You also have things about inputs, and we're going to jump directly to the output side and discuss those. So when we move to the output side here, you see we have several graphical output variables as well as some numerical variables. So once you get your inputs set the way you want them and you're ready to run your model, just come down here and click on the Run button. And as you do that, you'll see the graphical variables actually change in real time as we simulate day after day of the harvesting season. Over here you can see in this first variable we can see the loss of open cotton bolls. So with the way I have this thing set up, and again, I may have too many of the bot systems than you would actually have maybe in a comparable system. But with the way I have this set up right now, this is the amount of cotton that we're losing from open cotton bolls. So here's the deer system in green. Looks like we're getting a little higher loss than what the bot system is. But even in both cases, there's some losses that occur through the rainfall and potentially having a hurricane. Then we see right here we have the average days of suitable field work right here as that changes across time. We also have the days of available field work right here as more of a graphical variable here too, more of like a speedometer type thing. But this shows you as you actually go across your days what the average looks like. This next graph is fairly important because this shows you how much cotton you have in the field that is cotton as open bolls. That means whenever the cotton starts to open, there's probably a bigger chance of danger occurring at that point. Well, as you might imagine, with a bot system where you're running several bots and making multiple trips, you're less likely to have this big spike like you do to the deer system. Remember, in the deer system, we assumed the way the model was initially set up that you don't go through and start harvesting till about 70% of your bolls were open, and then you kind of go through and start desiccating fields to harvest at that point. So you actually build up a large amount of cotton before you get to the harvest point. But once you do start harvesting from here down to here, it goes fairly quickly and you reduce that fairly dramatically here. With the bot system, it's a little slower progress. So because the bot system is able to start as soon as we have open bolls in the field, we're able to get after those bolls and get them harvested. So you don't quite build up to as high a level as you had before, but then the decline is slower too. So actually we end up with some cotton here at the very end still to harvest, whereas with the deer system you would get done. So again, changing your parameters by how quickly or how many bots you have versus maybe the speed. And maybe when you start with the deer system, you can change these things. But with the way the model is set up right now is you're going to have more open cotton in the field with the deer system than you are with the bot system, even though the bot system will take a little bit longer to actually get done. Down here, again, this kind of reflects what's happening over here, but it's the density of ripe cotton in the field at any one point in time with this particular graph. Then we have some details. Again, this column over here, these first two, this is for the bot system only. It's about details about the bot system. So since we're running multiple bots across the same time and making multiple passes across the field, you will get a bot covering the same field several different times during the whole harvesting process, whereas with the deer system, conventional deer system, you are just covering that field once. So with the number of bots I have now, and the speed and such and the acre size, this is going to work out to basically covering our cotton field 6 times with a particular bot. So if you don't like this and you think this is too high, you can come back and maybe just lower the number of bots you have to get this to a lower number. But again, it's going to affect everything else if you start doing that. This is how many acres we're picking per bot. And remember, every bot's picking the field several times. So this is how many acres a potential bot would pick. This is not just the physical acres. This is actually going through and accounting for the fact that there are multiple trips across the field. And then we have the value lost of unharvested open cotton right here. We have the value lost due to quality declines. Anything from unopened cotton is here. This is right in the way the model ran right now. There was nothing lost because of unopened cotton which is what typically would happen if we actually had a hurricane event. Then we have value loss due to weather, and then we just sum all these, and here's the sum of quality and quantity losses right here. Over here then we have basically the information about the BOT system, about the Deere system. This very first quadrant, this is the BOT system. This is the cost per acre, whereas the second group right here, this would be your cost on a per pound basis. And the Deere system is similar. Here's your cost per acre right down here in this quadrant. Here's your cost per pound in the quadrant, in this quadrant right here. So currently the Deere system, the harvest, the amount of acres that we started with, we're saying this costs us $113 per acre. Whereas with the way the BOT system, the assumptions are made, we're saying this is $81. That doesn't mean necessarily the BOT system is better. It's just it's better based on the numbers I have entered initially in this. So this would be one way you could experiment with this if you're trying to design a BOT system to compete with the Deere system. Look at what the Deere system costs per acre, and then start plugging in different parameters you need for a cost to actually kind of make this comparable with the Deere system based on how fast your machine is going to travel and how many bots you would expect to have. So again, some what-if games can actually help you design a system that would compete with the Deere system. And we're kind of making the assumption from the start that unless your BOT system is going to be at least competitive with the Deere system, there's probably not a whole lot of reason to change away from the Deere system here. So you can do that with the per acre on the per pound basis, and then you can look at quantity and quality losses, and also the total cost per acre when you factor in both the cost up here for machine cost versus the quantity and quality loss you might look at from a cost perspective that way. So again, this is how you would use it and the kind of output that we're getting. Again, this is a work in progress, and we anticipate to have more changes as we get more information in the future. But that's it for now for this series of 3 videos about how to use the simulation model.